Maybe talk. Good afternoon, dear participant of the 7th International Workshop on Computer Modeling and Intelligent Systems 2024. Today I am second after Teterin Sergei, the head of the Education Scientific Laboratory, and the first after Professor Andrei Goncharenko. We would like to present the article to you, computer modeling of discrete systems in the case of discrete system in the case of linear and non-linear restrictions on the optimal speed of the aircraft based on the Lagrange method. Just a moment. On the second slide problem statement, we can see the description of the, we considered the problem statement of the present research concerning the theoretical studies focused on the calculation of the optimal speed on the aircraft as the key element of the aviation transport technologies. On the third and fourth slides, literature review. Some scientists who considered the problematic issues of the aviation industry, what is our options? There are still questions that need to be continued. Also wanted to draw you attention to the obtained values during the implementation of the study allowed to analytical and graphically determine the region of the optimal solutions, taking into account to limitations of the objective functions. And now I pass the word to the first after, Professor Andrei Goncharenko.
Thank you so much. Greetings again to all participants of our conference. Here's, as that was said just before, we have a problem how to determine the optimal speed for aircraft that delivers some goods or passengers to some points and in connection with some other route. So we consider this logistics chain, and we consider two links. Simplified problem. Equation number 1, it symbolizes this situation when the distance AB is divided by the sum of the aircraft speeds, V1 and V2. And the time of the delivery is this function of the two independent variables. So we consider some constraints. Formula number 2 describes this like a perimeter. So isoperimetrical conditions, it's a constant or idempotent value. And we propose to consider first, it's just a linear combination, like the difference in variation of two aircraft speeds. As this case, formula number 3, we can find the coefficients F1 and F2 unknown, and then using, I hope you can see formula number 8, it's the constraint equation. It equals identically to 0. On that condition, we may construct the extended Lagrange function formula number 9 with the uncertainty multiplier. And then in that case, we can search for minimal time of the delivery. And that will be ensured by the optimal speeds. So this is the general formulation of the problem once again. In this simplified case, we found there is no optimal solution because linear equation, it's here in the denominator. And as we will see on our diagrams, it was proved by computer simulations or computer modeling proved that. In that case, we propose to go on with our search for optimal division, optimal distinguishing between these speeds. Formula 20, it's a supposition of the connection of the second kind. So it's variated, as it's seen from here, it's variated portion of speed of the second aircraft as the connected to the first one. And we added here delta, function delta. I'm sorry, I have to go back. Yeah, here it is. So delta, and then we draw new equation 24 for constraints, and then new Lagrange, extended Lagrange function 25. Traditional procedure of the extremum search, so necessary conditions, first derivatives with respect to independent variables, and this system we solve and find from the system 27, we found two equations for the speeds which are optimal in this way. And this is illustrated with the diagrams, which I'm going to tell you about them just right now. So figure 5, you see three-dimensional plot. This hyperbolic plot, it's unconstrained time of the delivery. And this surface, plane surface, intersecting this hyperbolic surface, it has no minimal time. So this is the illustration that I mentioned with no extremum conditions for the first simplified case. For the second case, we have variated speeds like green and blue lines here in figure 7. And then, according to that, in figure 9, we can see the minimal time. Of course, we can consider it maximal time, but the objective function for us, it's minimization of the time of the delivery. So figure 9 shows this extremum point, minimal time, and figure 11 also shows that as the phase portrait. Red line, it's time with respect to the first independent variable, and the blue line shows this extremum distribution between speeds, 800 knots and 1000 knots, or kilometers an hour. That depends, of course, on the aircraft type, on many other conditions. So we may conclude here that optimization procedure with the use of the possibilities for computer modeling, it enhances, it makes much easier to solve for optimal solutions here. And computer simulation have been indispensable aid, and it was provided at our laboratory. So this is like the initial step in our research dedicated to optimization of transport technologies in aviation. So thank you very much for
Thank you
your
very much.
attention. Let us stop, how to stop this. Probably this one pauses.